Section: Introduction. We're here to talk about large language models, LLMs, which have shown great skill in understanding instructions and solving tasks across a variety of applications. However, these models, designed to assist with any task, often lack the human touch. They don't have personal experiences or emotions, which can make them less engaging in conversation. To make these interactions more engaging, some LLMs allow users to create profiles for their preferred characters. However, these models often just mimic the capabilities of more advanced models, like GPT-4, which has shown excellent role-playing abilities. This approach has its challenges, as it assumes that a more advanced role-play model exists, and we don't yet know how to build such a model from scratch without extensive manual annotation of datasets. In our work, we've developed a method called DITTO that allows LLMs to role-play through self-alignment, eliminating the need for more advanced models. We see LLMs as a superposition of characters, meaning they already have the conversational styles needed for role-playing and knowledge about many famous characters. To bring out these role-play capabilities, we only need to provide character profiles and attributes and then align the LLM to respond consistently with this information. Our method, DITTO, is scalable and flexible. We've explored 4,000 characters available on Wikipedia, creating a self-simulated role-play dataset called WIKIROLE, which is 10 times larger than any publicly available role-play dataset to date in terms of the number of roles. Evaluating role-play is tricky. Previous efforts have relied heavily on manual annotations, but this is costly and prevents comprehensive comparison of all relevant models. To simplify this, we've developed a way for LLMs to automatically score role-play. We assess whether the model can maintain a consistent role identity, provide accurate role-related knowledge, and reject unknown questions beyond the character's background. We've tested DITTO on Qwen chat models of different scales. Our experiments show that DITTO effectively gives LLMs role-play capabilities without needing to mimic advanced chatbots. DITTO based on Qwen 72B chat even achieves 90% on role identity consistency, showing strong self-awareness in role-play. However, while the general performance of Qwen 72B chat can match advanced chatbots like GPT 3.5 Turbo, it falls slightly short on accurate role-related knowledge compared to GPT-4 and Qwen Max. We've also analyzed the role-play process by extending our self-alignment setting to cross-supervision. Our experiments show that consistent role identity can benefit from imitation learning, while knowledge-related metrics do not. We've also found that knowledge in role-play is limited by the inherent capabilities of LLMs. Our main contributions are threefold. 1. We've proposed DITTO, the first self-alignment method that gives LLMs strong role-play capabilities by augmenting knowledge and simulating dialogue. 2. We've designed an objective role-play evaluation that focuses on consistent role identity, accurate role-related knowledge, and cognitive boundary. This evaluation is reproducible, explainable, and efficient compared to manual annotations. 3. We've analyzed the role-play process by cross-supervision, providing insights into the keys of role-play capabilities. Our experiments show knowledge boundedness in strong to weak imitation learning and the weak to strong generalization in role-play styles. Section Summary. Large language models, LLMs, are highly proficient in understanding intent and solving tasks, but lack experiential events and emotions, limiting their ability to engage in extensive conversations. To address this, role-play LLMs allow users to define and create profiles for characters, but existing methods imitate proprietary models and lack a clear understanding of building such models from scratch. In this work, we introduce DITTO, a self-alignment method that enables LLMs to engage in role-play without relying on more powerful models. We also propose an objective role-play evaluation that focuses on consistent role identity, accurate role-related knowledge, and cognitive boundaries, providing insights into the keys of role-play capabilities. Section: Related works. Our research falls under the category of character-based dialogue systems, which are designed to mimic the speech and behavior of specific characters. Previous studies have tried to train language learning models, LLMs, to roleplay based on specific character descriptions, but they face difficulties in accurately reflecting the relationship between the character profile and the dialogue content. Some researchers have evaluated how well an LLM can align with a specific character, using Harry Potter as an example. Others have introduced the first detailed role-playing dataset containing 100 roles by prompting GPT 3.5. They included extensive prompts about the character's background, personality, and previous conversations, and used ChatGPT to generate dialogues of 32 characters. Further efforts were made to prompt GPT-4 to expand the scale and diversity of human annotated role-playing data, resulting in 1,034 dialogues of 250 characters. Some researchers also prompted GPT 3.5 to become the role-play data generator. They proposed creating role-playing dialogues from diverse Chinese novels and scripts with the help of GPT-4. However, due to limitations in data sources, they could only construct a Chinese dataset containing 77 roles. In contrast to previous works, we have decided to stop imitating proprietary LLMs and build role-playing training data entirely through self-alignment. Our method separates character knowledge and conversation style, making it compatible with any LLM that can follow instructions. It is highly scalable, creating the first multilingual dataset with 4,000 roles, which is 16 times the number in previous works. We show that our model achieves the best role-playing ability to date through self-alignment, surpassing even proprietary LLMs like GPT 3.5 Turbo. Self-alignment is a new method to cheaply improve a weaker language model by fine-tuning it on outputs from a stronger model, such as a proprietary system like GPT-4. However, it has been found that model imitation is not a free lunch. It is good at mimicking GPT style, but the factuality is weak, thus fostering hallucination. This is due to the substantial capabilities gap that exists between open and closed language models. In this paper, we observe that LLMs inherently acquire styles and knowledge of a vast array of roles during pre-training. Therefore, by self-alignment, we can effectively stimulate the LLM's intrinsic role-play abilities, leading to the attainment of the current best role-play models. Role-play requires LLMs to engage in dialogue, embodying specific characters to facilitate immersive interaction. Therefore, a role-playing LLM must exhibit unwavering self-awareness and possess extensive character-specific knowledge in adherence to query instructions. In this study, we define the role-play task by providing LLMs with either a name or a brief description of a particular character. Then, we assess their ability to maintain consistent self-awareness and demonstrate nuanced role-specific knowledge across multi-turn conversations. We introduce DITTO, a self-alignment method for arbitrary role-play scenarios. The idea behind DITTO is that LLMs are the superposition of all characters, as they are pre-trained on a large corpus, including conversations on various styles and domains. We break down role-play into two key components: consistent self-awareness and role-specific knowledge. To achieve these goals, DITTO includes 3 steps for constructing datasets tailored for role-play alignment: character knowledge collection, dialogue simulation, and supervised fine-tuning. DITTO operates on a readily available LLM chatbot, such as QuenChat, LlamaChat, or Mistral Instruct. These open-sourced LLMs have already shown commendable instruction-following capabilities but still lack role-play capabilities. DITTO simulates role-play dialogue by reformulating it as a reading comprehension task, using role profiles sourced from open-access knowledge bases to generate a role-play dataset. Then, we fine-tune the LLM using this self-generated dataset to imbue it with role-play capabilities. Diverse characters and corresponding precise profiles are essential for generating high-quality role-play supervision. As its foundational step, DITTO gathers comprehensive profiles from open-source knowledge bases. In this study, we use Wikidata and Wikipedia to support DITTO, although DITTO can easily adapt to alternative knowledge bases. We collect character names, descriptions, and key properties from Wikidata, along with the corresponding Wikipedia article serving as the character profile. While we currently focus only on Chinese and English characters, DITTO can be extended to more complex multilingual scenarios, as Wikidata and Wikipedia have rich content in numerous languages. Section Summary. In this section, the authors discuss related works on character-based dialogue systems and role-playing. They highlight the challenges in accurately reflecting the relationship between character profiles and dialogue content. They introduce their own method called DITTO, which uses self-alignment to train language models for role-playing. They explain the 3 steps of their method: character knowledge collection, dialogue simulation, and supervised fine-tuning. They also mention that DITTO can be extended to multilingual scenarios using knowledge bases like Wikidata and Wikipedia. Section: Dialogue Simulation. We simulate dialogues for roleplay by using the character knowledge we've gathered. This process involves 2 steps: creating queries and generating responses. In the first step, we use a language model to generate queries that are relevant to the character's role and contrasting to it. Role-specific queries are questions that are closely tied to the character's background. For instance, a question about the Cheshire Cat would be a role-specific query for Alice. On the other hand, contrastive queries are questions that are beyond the character's knowledge. For example, asking Alice about stories from Family Guys. To generate these queries efficiently, we pair characters and provide detailed profiles for the language model to generate questions that one character can answer but the other cannot. In the second step, we treat the response generation as a reading comprehension task. We provide the language model with the queries and character profiles, and expect it to extract relevant information and generate responses that mimic the character. We believe this approach can reduce inaccuracies compared to previous methods. We then fine-tune the language model on the generated dataset to enhance its role-play capabilities. During this process, we only retain a brief introduction of the character, which helps the language model retrieve character profiles and inherent knowledge. Evaluating role-play is a challenging task. Previous methods relied heavily on manual annotations, which are labor-intensive and not easily reproducible. We propose an objective assessment to evaluate basic role-play capabilities. We design 3 core metrics for role-play and implement an evaluation method for each. The first metric is consistent role identity, which assesses whether the language model can maintain character consistency throughout a conversation. We structure this assessment as a multiple-choice problem, where an additional language model is tasked with identifying the most suitable character from given options. The second metric is accurate role-related knowledge, which evaluates whether the language model can accurately convey the knowledge associated with the role. We use our dialogue simulating scheme to acquire the necessary knowledge for each round of role-play dialogue and provide this knowledge as tips to a judging language model. The third metric is unknown question rejection, which assesses whether the model can reject questions that are beyond the cognitive boundary of a specific role. We manually annotate all questions in the test set based on the cognitive boundary of each character and use a language model to evaluate whether the model rejects each question. In summary, our approach to dialogue simulation and evaluation aims to enhance the role-play capabilities of language models and provide an objective assessment of their performance. Section Summary. In this section, the authors describe their approach to dialogue simulation, which involves generating queries and responses for characters in a role-play setting. They use a language model to generate role-specific and contrastive queries, as well as responses that emulate the character. They also propose objective metrics for evaluating role-play capabilities, including consistent role identity, accurate role-related knowledge, and the ability to reject unknown questions based on the character's cognitive boundary. Section: Experiments. In this section, we'll discuss our experimental setup, the main findings of our study, and further analysis. For our experiment, we gathered data from Wikidata and Wikipedia, extracting profiles of 3,902 characters in both English and Chinese. This method can be extended to include more characters from various wiki databases in different languages. To explore the impact of language learning models, LLMs, with different instruction following abilities, we used Quen's 1.8b, 7b, 14b, and 72b models to generate 4 sets of training data. To avoid any biases in the training data that could skew our evaluations, we used GPT-4 Turbo as the base LLM to create a separate test set. This test set included 100 roles, each with its own session, resulting in 498 chat turns. We compared our dataset, WIKIROLE, with others and found that it had the highest number of roles and conversation sessions, making it a strong dataset for studying the role-play dynamics of LLMs. We tested our benchmarks on both open-source and proprietary advanced chatbots, including OpenChat -3.5-1210, Mistral 7b Instruct v0.2, MIXTRAL 7x8b Instruct v0.1, Claude 2.1, Wenshin 4.0, API, GPT 3.5 Turbo, GPT-4, GPT-4 Turbo, and Qwen Max. We also included LLMs with role-play expertise, such as Character GLM and Tongyi Xingchen. For our experiment, we used 4 sizes of the Qwen chat series as our seed LLMs. These models have basic instruction following abilities but lack role-play capabilities. We trained these models on 32 A180G GPUs for the smaller models and 64 A180G GPUs for the larger model. We trained all models for 5 epochs with a learning rate of 2 × 10⁻⁻⁷, a 0.1 warm-up rate, and a sequence length of 8,192. Our main findings showed that proprietary models generally outperformed open-source models. For instance, OpenChat 3.5 performed better than GPT 3.5 Turbo on various benchmarks but still lacked in role-play. We also found that role-play expertise baselines had better self-awareness consistency and cognitive boundaries than general baselines. However, both Character GLM and Xingchen scored low on knowledge, suggesting they lack role-specific knowledge. Among the proprietary LLMs, Qwen Max outperformed GPT-4, achieving the highest scores on the current role-play benchmark. When we tested DITTO on 4 different seed LLMs, we saw a significant increase in all metrics along with the parameter scale of LLMs. DITTO built on Qwen 72b even achieved 0.9 on consistency, surpassing all baselines and showing strong self-awareness consistency. It also scored 6.64 on knowledge and outperformed all role-play expertise baselines. In conclusion, DITTO shows robust effectiveness on LLMs in different scales, and the best model trained on Qwen 72b surpasses all role-play expertise baselines and reaches the performance of advanced proprietary chatbots. Section Summary. In this section, the authors describe the experimental setup for their study. They extracted characters from Wikidata and Wikipedia to create a dataset for their experiments. They also used various LLMs as seed models and generated training data. They tested both open-source and proprietary chatbots as baselines. The main results show that proprietary models outperform open-source models, and role-play expertise baselines have better self-awareness consistency and cognitive boundaries. The best model trained on Qwen 72b achieves high scores in consistency, knowledge, and rejection, surpassing all baselines and reaching the performance of advanced proprietary chatbots. Section Analysis. We're going to delve into 2 additional aspects of our study: the quality of the queries and the effectiveness of injecting knowledge. Firstly, we wanted to better understand the quality of the self-simulated queries in our model, DITTO. To do this, we had human annotators review the quality of these queries. We took a sample of 400 queries that were generated by Qwen Chat, which were divided equally between role-specific and contrastive queries. The annotators were asked to verify if a question met the criteria for either type of query for a specific character. The results showed a significant increase in the accuracy of query simulation as the number of parameters increased from 1.8 billion to 72 billion. This suggests that stronger language models generate more accurate queries, which in turn leads to better role-play performance. Secondly, we analyzed the effectiveness of injecting character knowledge during the dialogue simulation in DITTO. We compared the quality of dialogue simulation by applying this method on WIKIROLEEVAL with Qwen 1.8b chat as the base language model. The results showed that the setting with knowledge injection consistently performed better on all three metrics, especially knowledge and rejection. This indicates that injecting knowledge can significantly improve the quality of self-simulated supervision. We also noticed that a stronger language model supervising itself yields better results compared to a weaker one, with a particularly significant improvement in knowledge. However, the improvement in conversational style, such as identity, was relatively limited. This led us to two interesting questions. Is the improvement due to the higher quality of supervision, the larger capacity of the model, or a combination of both? And, is high-quality supervision necessary to simulate role-play style? To answer these questions, we conducted a series of cross-supervision analyses to see how different combinations of supervision and language models affect the outcomes. We introduced three terms to extend our setting from self-supervision to cross-supervision: supervision language model, supervision performance, and imitation performance. The supervision language model is the model we use to simulate role-play dialogue in DITTO. The supervision performance refers to the performance of the supervision model on the test set following the simulation recipe of DITTO. The imitation performance is the performance of the base language models on the test set after fine-tuning on role-play simulation from a certain supervision language model. Our experiments used 4 Qwen chat models ranging from 1.8 billion to 72 billion as supervisory language models. All models underwent training using nearly identical pre-training and alignment procedures, ensuring uniform initial conditions. We used each of them as the supervision language model and fine-tuned all 4 models on each simulation. Our results showed that consistent role identity can benefit from imitation learning even with worse supervision, while knowledge-related metrics do not. We also found that the inherent capabilities of language models in strong to weak settings limit the knowledge in role-play. Using supervision from significantly stronger language models may only yield slight improvements. We also observed consistent weak to strong generalizations on knowledge-related metrics but not in role identity consistency. For example, using weak supervision, such as simulations on QWEN 1.8b chat to fine-tune Qwen 72b chat, can achieve on-par performance on self-aligned Qwen 7b chat. Despite our definition and experimental settings being different, both works empirically show the potential of eliciting strong capabilities with weak supervision.